All right, so now that we've got this calculate function, I want to show you how it can be used and how it really can be used in a generic way, because major parts of this whole calculate function are still going to be defined by the caller. So the caller really can influence what should be happening with this calculate function. So first, let me write an add function again, similar to the function that we had on the slides in the previous videos. So it would be a function that takes two integers and returns an integer. And now we just return the result of the addition of these two integers. In a very similar way, we can also write a multiply function that is just going to replace the addition with a multiplication. All right. So how can we now go and use the add and the multiply function in combination with our calculate function? Well, basically we can use it as we expect. And on the on one of the slides in the previous videos, we actually saw what it looks like when we're calling a function and passing in the name of another function as an argument. So it would look like this, that if we want to make an addition with two numbers, we just call the calculate function, and we're passing in the two numbers that we want to use for the computation. And then as the third argument for the function, we're just going to specify the name of the add function right there. And now we can go ahead and see the result of this computation right here in the right pane in the playground. And in a very similar way, we can use the multiply function as well, that we're passing in and using the calculate function to calculate the result for us, but specifying the actual behavior on the call side. So we are telling the calculate function on the call side what operation we wanted to apply to the two integers that we're passing in. And we see that the result in this case becomes 50. And the reason for that is because this my function here, this call to my function with the two values a and b, actually is either a call to add or to multiply. So we're not passing in a result, an actual value. We're passing in a function that can be used inside the calculate function to compute a certain result. All right, so next I want to show you how we can go from using a function with a name and passing this as an argument to going of passing a closure. And I'm going to do that in a very similar way as I showed you on the slides, but here I'm going to make a live example for you to demonstrate how it works. So let me do this with this call to the calculate function where we're passing in the add. And in fact, we can go ahead and just follow the 4 steps that we saw in the previous video. And for that, I just want to show you how we can go from using a function with a name to a closure using these 4 steps. So for that, I'm actually going to copy the whole definition of the function add, where I had the add name as an argument for the my function. And I'm going to follow the 4 steps that you find on the slides. And the first step is to remove the curly braces. And the second step is to add the in keyword between the argument list and the return type, or between the function signature and the function body, actually. So between the return type and the implementation, we add the in keyword. Then we need to remove the argument name, the function name and the func keyword. And then finally, we enclose everything with a pair of curly braces again. And this is what it looks like when we're passing in a closure that has the same functionality as the original add function into the call to the calculate function. All right, but notice that in the moment when we're passing this function here, the function does not get executed. We're just passing all this information as to what to do to the 2 input arguments to the calculate function, but it will only be called when we're actually calling the calculate function. All right, so now that we know how to pass in a function as an argument and a closure as an argument, I want to show you the syntactic sugar that I also mentioned in the previous videos. So first, when we're dealing with closures, because it is actually very often the case that a closure is the last argument into a function in general. And what this means is that we can use what is called the trailing closure syntax for the cases, for the scenarios where the last argument of a function inside the argument list is a closure. So rather than having to enclose this whole thing with our parentheses from the argument list, we can actually get rid of the last argument name. We're closing the argument list right there, and we're using the trailing closure syntax that allows us to pass the last argument, which is a closure, not inside the argument list, but actually outside of the argument list. But it's still connected. It's still the same notation as passing it, or the same meaning as passing it inside the argument list. It's just a shorthand notation. Then, when working with closures, we also can always get rid of the return value in the function signature. So this value will actually be inferred by the Swift compiler now. But even better, we can also get rid of the type specifications inside the argument list. So we can just go ahead and remove the parentheses along with the type specifications. And again, the compiler will be able to infer the types of A and B. But wait, there is more. There is even more shorthand notation that we can apply here. Because in some cases, we actually don't want to give names to the arguments. It might be more convenient to just refer to them in an even faster way. And this we can do by using the $sign. $0 will refer to the first argument name, and $1 will refer to the second one. So now we are referring to the two arguments, and after getting rid of the return in here as well, because it's clear it's inferred by the compiler that the only value that we have here is being returned, this is what we might end up passing into, and it has the same functionality as the whole closure that I showed you in the beginning.